Sam from DMTI. In this video on the 10 rule, we're going to build off what we did in the introduction, as well as a multi-digit place value based 10 rule multiplication to connect to help explain what is often one of the hardest things for kids in the intermediate grades to make sense of, and that is actually multiplying a decimal by a decimal. If you've ever taught this, you know that a lot of students think 2/10 times 3/10, they want it to be 6/10, but it's actually 600. So we're going to talk about how to model and describe why a decimal multiplied by a decimal ends up being a product that sometimes is a little counterintuitive. So the first thing we've started with is a diagram that shows 2 iterations of 3. So I'm talking about this first part of the problem, this first number, as the number of times we're going to copy, which is iterating, and this is the part that we're going to copy. So I have 3 iterated 2 times, and we end up with a product of 6. Now in our problem string, we're going to look at 2 times 3/10. So using that same language, we're saying we're taking 3/10 and we're iterating it 2 times. So in our model, I'll just go in and use this unit of 1 here in the model we've already drawn to show this. So the first thing I need to do is partition down to tenths. And then I need to take 3/10 right here. So that's 1 3/10, and now I'm going to iterate that 2 times. So I have 2 copies of 3/10, and I end up with a product of 6/10. That's what's in this area right here. A little more difficult version of this is if we actually take 2/10 multiplied by 3. Now, those of you that are comfortable with commutative property know that it's going to end up being 6/10. But the real life situations that match this number set are a little different than this one. And it's a little harder to make sense of in model. So the commutative property is very helpful in understanding that. But the first step would probably be to make sense we know why this ends up being 6/10 in a different way, because that will actually help with some ratio proportion ideas later. So the way I'm going to think about this is I have a whole number 3, and I'm going to find 2/10 of it. So I'm not even going to iterate a full 3. I'm basically partitioning, which means to split. So in our model here, I'll start with these 3 units of 1. So that's the 3, and I need to find 2/10 of it. But what I can do first is find just 2/10 of 1. So I can find 2/10 of 1, and then if I do that 3 times, I'll end up with the final product. So I'm going to start here. Okay, and I'm going to find 2/10 of 1. And then if I just repeat that process, I've got now 2/10 of 2. But my goal was to find what's the product of 2/10 of 3. So I need to repeat the process one last time. Okay. So now I've got the 2/10 of 3, and if we recompose that all together, we'll actually end up with the 6/10 that we had over here. It's just a different arrangement and a different diagram. So we get to 6/10, it's just a different process. So the last one was our target problem, which is a little more difficult, and that's to find 2/10 times 3/10. Well, the reason why we went through all this process here that might have seemed a little extended and lengthy is to actually help us understand what happens with this new number set. So we don't have any whole numbers, but what we can do is build off this idea and say, okay, 2/10 of 3/10 is kind of difficult, but I could probably find 2/10 of 1/10 fairly easily. So I'm going to move over to this last unit of 1 and just partition down to tenths. Okay, so I've got tenths now, and again, I'm just working in this unit of 1 for right now. And I'm going to find 2/10 of just a single tenth. So I'm going to partition this tenth. I'm going to find just 2/10 of it. Okay? Now, we're not going to name those units just yet. But that wasn't our problem. Our original problem is 2/10 of 3/10. So I need to repeat this process 3 times. So I'm going to find hold on, I need to pause that. Okay, I've jumped ahead a little bit here just to make this a little bit easier to show that I found tenths of each of these 1/10. So we started with 2/10 of 1/10. There's 2/10 of 2/10, and then the 2/10 of 3/10. Now, in order to name what units those are, we're actually going to partition all of the tenths in the same way. And what we end up with is hundredths. So the answer to 2/10 times 3/10 ends up being 600ths. Now, that's the way to model it and explain what's actually happening. Building on what we've talked about with the 10 rule with other numbers, we can also start here and say, well, 2/10 or 2 times 3 is 6. 2 times 3/10 is going to decrease by 1 place value to 6/10, and then 2/10 times 3/10 will decrease 2 place values to 600. So now we're going the opposite direction of what we did in the other videos where we were increasing by a place value. Here we're decreasing by a place value each time. So I hope that's helpful and gives you some tools to explain what's happening when we learn to multiply decimals.